logic and run these units. Kind of an interesting... Or distribution for 125 volts, million voltage of some sort.
Yeah, very small.
But a monitoring system or a governing system or whatever, I mean, and your vibrations, your flame monitors, your speed detectors, all of these things all interface with this stuff. We're pumping 123 volts DC into the rotor, so it creates 3 magnetic fields for your 3-phase generation. Pushes your electrons through your stator wires and out through the phase tubes, 3 phases, 3 tubes. There you go. Piezoelectric vibration monitors also. Whatever you want to call it.
Potato.
Yeah. The other kind.
Well, actually, the plugs for the weights are already set. So you have the eccentricity is set, right? Like there's a hole that you put your weight in already.
Yeah, and actually that's part of the photos that I started pulling out. Is I've got pictures of those shot. We call them, they're balanced planes is what we call them. But they're the holes that we screw these in. I only showed you half of it, but the other half is this plug. We drop these balance weights in, and then we screw this plug down.
Right.
And that plug actually just locks that balance weight in.
Okay.
But these are all the same weight, and they're
right.
But it is part of, and that's kind of why when they sell them like this, and as a set.
Right.
It's all part of the same measurement of weight.
Well, that's good. So you have the big M already set, and the eccentricity. So all you got to do is solve for the small m, and you're done.
And really, for balance, for our purposes, we're going to call the z-axis the axial movement of that machine. We don't set that with vibrations. We set that with thrust pads and thrust collars and thrust absorbing bearing and things like that. We don't mess with that. All we're talking about is X, Y.
Right.
Which really, X, Y is a circle.
Yeah, makes it much easier.
Basically, it's plugged in, and
does it have mounts that you could hold it up to the shaft so it's a steady? Yeah.
So what happens is you have your magnet. Magnet goes into your probe. Probe plugs into port on your data connector, basically, right there, and then you take readings. Now this thing is just a magnet. It sticks to various points on a pump or a motor or a fan, whatever, and you set this up, and it actually has a route built into it. So it makes it real easy for anybody just to say, okay, next pump, this and this, point 1, point 2, point 3. Next motor, point 1, point 2, point 3. And you just kind of go down the line. And all of that data gets saved into this, and then that data will get uploaded to be analyzed by a higher level vibration guy. He can go through and he knows what these accelerations and these different things
will be used.
No. But that's how that works. So it's kind of interesting, and seeing, this is what they